So we're going to be talking about introduction to a relative extrema here. So we have some rules we already knew. If f of x is increasing, then our f prime of x is positive. And if f of x is decreasing, our f prime of x is negative. So the new ones now are, we're going to be looking at where our possible relative extrema is, and that's our max and mins. So what you have to think about is you have this situation, and that is a relative max. And you'd have this situation, and that's a relative min. So when do those occur? Well, those occur when your f prime is 0 or your f prime is d and e. And that's going to give you your critical number, and that's when we get our possible relative extrema. So let's look at this graph here, and you'll see why these are the situations that we need in order to have critical numbers, and those giving us our relative max and min. So if we just graph this, you can see our graph goes up. It's positive, right? So it looks like this. Our function is increasing, and so you can see our slope is positive, and then it's going to hit some peak here, and then it's going to go negative, and then some little bottom peak, and then it's increasing, so positive. So positive slope, positive slope, and then it's negative because we're going down. See, dot goes down, it's negative, dot goes up, positive. So let's mark our graph with those measurements. So then it goes negative to here. There's a dot, and then it goes positive, and then there's a dot, and then we're going down. So again, that's negative to right about there, and then we go positive, and then we go negative. So all of the f prime in red are going to be negative, and all the f prime in blue are going to be positive. Well, what happens when you go from a positive to a negative? So like this, if we had our tangent here and we say that this is some positive like 5, and then we're going to go to here, and that's some negative, say like that's a very small, like a negative half. Well, in order to go from 5 to negative 1/2, what number do you have to go through? 0. You have to go through 0, which means that point right there would have to be our f prime of x of 0. So that is a maximum. So you can see we went from an increase to a decrease, we get a maximum. So that's when our maxes occur. We have an increase to a decrease. Oops, let's do that in red. And we get a max. And when we have a decrease to an increase, we get a min. So like here, you can see it's going down, and then it's coming back up. And that, again, is when we have our f prime of x equal to 0. Well, this situation also occurs when we have our d and e, like here, or here. So it looks like this graphically. So as we're going through it, we're increasing, slope of 0, that's a max. Decreasing, slope of 0, that's a min. Increasing, d and e, see how it disappeared? So that would also be a max because it increased and decreased. And then now we're decreasing, slope of 0, increasing, that's a min. And then we're increasing, undefined, decreasing. And so you can see it just disappeared. Derivative looks like this. So you can see it's coming in and leaving at 2 different points. That's our undefined, our d and e. Undefined d and e. So you want to look for those situations. So if I click on the graph, you'll see that they pop up very clearly. We'll talk about the other ones later, those other little dots that were on there. But you can see we have a max at -2, a min at -1.366, a max at -1, a min at 0.35, and then again a relative max here at 1. And so these two, -1.36, -1, 0.35, and 1, these are all of our critical numbers. So the x value that gives us the 0 or the d and e is our critical number. And again, those are going to give us our possible relative extrema. Okay, so for this following graph, for what values of x is f prime of x equal to a positive? So again, all we have to do is trace. And if while we're tracing, I'm going to make this a little larger here, if while we're tracing, we're going up, then we know that is f prime of x equal to a positive. And if we're going down, that, we know that's an f prime of x equal to a negative. So we just continue that. But as you can see, what it happens is those critical numbers right here. We know our x equals 1 and x equals 5. These are our critical numbers. It's where our possible relative extrema occur. So we know that f prime of 1 is equal to 0, and we know that f prime of 5 would be equal to 0. So if you know those values, you also know when is it going to increase and when is it going to decrease. So we know it's going to increase from negative infinity to 1, union, and then 5 to infinity. So from that negative infinity to that critical number, and then from that critical number to infinity, we know we're going to get positives. And it'll be negative from 1 to 5. So we're just entering the x values that will give us that value. And so when does it equal to 0? Well, that's when x is equal to 1 and x is equal to 5. So if you know the critical numbers, you know where the relative extrema occur, and you also know when is it increasing and decreasing. So the whole point of this is if they ask you for any of this stuff, when is it increasing? When is the derivative equal to negative? When is the derivative equal to a positive? When does the derivative equal 0? Any of these questions, they all have to deal with the derivative equaling to 0. This is the important one to find first. Okay, so we do that exact same situation here. So where are the relative minimum and maximum values? So relative minimum and maximum values are where we get that increase to decrease. It's where our derivative is equal to 0 or d and e. So what are the relative minimum and maximum values? So we have a relative max at 8 when x equals 3. And we have a relative min at 4, of 4, we should put of, not at, of, when x equals 5. So when they ask you for the relative min and max, you're looking for, again, that increase to decrease where that derivative is 0 or undefined, or d and e. So increase, decrease, that's a max. Decrease, increase, that's a relative min. And so why they call it relative is we're just looking at that relative point. So if you zoom in on just that little point, that looks like a min or a max. So the next question they're going to ask us now are what are the absolute min and absolute max values of this function? And so what they literally mean is the highest point and the lowest point. So the minimum is the lowest and the maximum is the highest. So the highest y value that we get, highest y. Okay, so if you look at it, we have to include the endpoints as well on these. So if you look at our graph, we're going to go from 7.125, this one right here, up to 8, back down to 4, and then back up to 14.125. So the lowest y value would be 4. So we have an absolute min of 4 at 5. We'll put when x is 5. And we have an absolute max of 14.125 when x equals 6.5. So when you're looking for absolutes, you also have to include the endpoints. So for relative min and max, we're going to be looking for critical numbers. And when we're looking for absolute min and max, we're going to be looking at critical numbers and endpoints. All right, so in the next video, we're going to try some of these.